All right, last one here, but a big one. The coverage code decoupling point. Now, the decoupling point takes into consideration the priority coverage code in terms of using a minimum, reorder point, and maximum, and allocating a priority to planned orders that come out of there. But it's also taken into account the average daily usage, lead times, and of course, decoupling points on particular raw materials that are telling the system, hey, we plan on having this raw material on hand at all times as a buffering warehouse. But to talk a little bit about the purpose of the decoupling point, it's essentially to shorten the supply chain vulnerability by maintaining a reasonable amount of on-hand inventory for raw materials that have a significant lead time. That's the trick there. Essentially creating a buffering warehouse. Such items are designated as decoupling points, and when successfully implemented, the production lead time for a finished good with offshore sourced raw materials can reduce drastically because we're no longer having to factor in to our effective production lead time the time it takes to get something from overseas, let's say a semiconductor from Taiwan, for example. So moving on, I want to add that as part of this decoupling point demonstration, I've added lead times to some of the raw materials and used a subcomponent to see how that decoupling point can filter up to a parent level item. Some of the reasons why you might use the decoupling point is if you have, of course, a volatile supply chain, but also raw materials that are used in multiple finished goods or bottleneck operations that will cause serious issues if they're out of stock. Also, items that require a short production lead time, something you really got to get out the door on time. Let's head over now to the coverage group so we can start from the top and check out some applicable fields to our DDMRP that we have to have configured correctly for this to work first. So currently you can see that we have the coverage group on our item coverage for our finished good, as well as the coverage code decoupling point. So let's just jump into our coverage group in order to see those special fields. It's worth noting that once you apply the coverage code decoupling point to the coverage group, you're not getting rid of it. It can't change. And so if you're just playing around with your coverage groups and you select decoupling point and save it, you're stuck with it. You'll have to create a new coverage group if you don't want to use decoupling point. But the first field that we have to look at is going to be the lead time factor. And so a lot of these DDMRP parameters are going to be in the other tab. Coming down here to DDMRP parameters, we have the lead time factor. Now, the lead time factor helps determine the quantity and frequency of reorders. Essentially, the lead time factor is a multiplier on our min and max reorder points. The lower the lead time factor, the lower our min and max, resulting in more frequent and smaller orders. In order to avoid a bullwhip reaction, we use 3 different ranges depending on component criticality. And for those who don't know, a bullwhip reaction is essentially a single delayed component that can produce a domino effect of delays for a finished good due to over ordering, inventory swings, and misaligned forecasting, and all that fun stuff that results from an issue. The recommended ranges by the Demand Driven Institute for our lead time variability here, our lead time factor, is going to be based on our longest and shortest lead times. And the ranges for that factor are from 0.2 to 0.40, 0.41 to 0.60, and 0.61 to 1. Those are the recommended ranges for essentially low to high when it comes to our lead time factor. Here, just for demo purposes, I'm going to leave them as 1. The variability factor right below it here, this is going to help determine our minimum stock level. Essentially, the lower our variability factor is, the lower our minimum will be. For more variable items that might stay on the shelf for a while and then suddenly be consumed at a great rate, we can increase the variability factor to raise the minimum stock threshold and provide that buffer. Again, we can use those ranges 0.2 to 0.4, 0.41 to 0.60, and 0.61 to 1. Min, max, and reorder point period field right down here. This tells DDMRP when to recalculate item buffer quantities based on our chosen parameters. our item buffer quantities are going to feed into those planned orders that we're going to be creating. And so essentially, in order to determine the quantities for those planned orders, we need to tell, we need to tell DDMRP how often on what data period we want that to be calculated. And so we have two options here, daily or weekly. We have the average daily usage based on, and three options, past, forward, and blended. Essentially, DDMRP needs to know the time horizon for calculating inventory data to use in its calculations. That's where the ADU comes in. The average daily usage can focus on an item's past data, future demand in the form of future orders and forecasts, or a blending of both. If we choose blended, we also need to tell DDMRP how much to focus on, either the past or future, which is where the relative weight fields come in. Right here, we can see that relative weight of past period for blended average daily usage and forward period for blended daily average usage. And you can see when I select blended, I have those available to me, as well as the forecast model for that forward look. Or if I just choose forward, I only see the forward period in days in the forecast model. Or if I choose past, I'm just looking at that past data. That means real orders, real consumption that is occurring. And consumption can range from production orders, disposals, journal adjustments, like through the inventory adjustment journal, whatever's going to be consumed. Any kind of consumption in the system that's going to feed into our ADU. Okay. And real quick, if you are interested, I'm popping up here on screen the calculation. There's a few different equations to think about when it comes to DDMRP, and this is one of them. The blended ADU is pretty simple. It's just taking that past ADU times its weighting over here, forward ADU times its weighting, and then divided by the sum total of the past and forward weighting. Okay. So we can pop back over to our item coverage now and take a look at our decoupled lead time. Because remember, that's kind of the beginning of figuring out how to plan correctly with DDMRP. We need to establish what is a decoupled point by assigning the decoupled point coverage code. And then, based on the lead times that we have, calculate with the system what the true decoupled lead time is going to be for our produced item after we tell the system, hey, this raw material over here, that's going to be decoupled. Don't worry about its lead time. So clicking on back here, we can come up to our decoupled lead time. All right. And so what I've done here is I have our regular make item, P1004. It has another raw material item right below it. And then also a sub BOM. Okay. And that sub BOM has 3 raw materials. One of those raw materials is a decoupling point. I also have our finished goods set as a decoupling point just for demonstrative purposes, which I'll get into later so we can do calculations there. But here we have a classic decoupling point that would be used on a raw material. We can see that the lead time here on it is 25. Ouch. We want to avoid that if possible. And so we're claiming that as our decoupling point. We're going to have that on hand at all times, hopefully, when we're producing. But when it comes to these shorter lead times, 4 days, 10 days, okay, 6 days, we don't care. That's all right. But you'll notice that right here, that sub BOM, that sub finished good, is going to have its decoupled lead time as 10 instead of 25. Typically, what the system is doing is it's looking at all of the sub materials and choosing the highest number that is not a decoupling point, and then claiming that as the decoupled lead time for the make item. And so here it's looking at 25, 4, and 10. It knows 25 is decoupled, so we're ignoring that. And the highest between 4 and 10 is, of course, 10. So that becomes our decoupled lead time. Our parent level finished good then looks at its single raw material of 6 lead time, and then its sub BOM lead time of 10. 10 is bigger than 6, so it chooses 10 as its own decoupled lead time. We can calculate this out by selecting Calculate the Decoupled Lead Time in the action pane. This is particularly useful if you have a really complex BOM. I've worked in some companies where they have to use their BOM designers in order to really get the BOM design function here in D365 in order to really get their head around what they're making, because they might have 10 different sub-BOMs. And so having the system calculate all of these different decoupled lead times for you is a big help. And so we can determine the date and quantity associated with our storage dimension in order to help choose a BOM, or we can select it from our drop down here and then select OK. And I've already done that, so we're not going to see any changes here right now. But bear in mind, you can manually change the decoupled lead times. Let's say, for example, on this one here, I want to change that to 8. We can do that. We can refresh here the page, and we're going to see that 8 reflected. You know, I can make this 8, perhaps 12 if I wanted. Refresh again. All right. And when I calculate again, we can see that filter back up to the main item. But really, we should be relying on our lead times in this field here that's coming from those, could be default order settings, could be safety margins, could be a couple of different places that are filtering up in order to give the lead time for this particular item. All right. And so again, the decoupled lead times are calculated by choosing the longest lead time for a non-decoupled component. And the field lead time here is going to be that lead time for the specific item, for example, coming from the default order settings. All right. Great. So we've developed our decoupled lead time. Let's go back and take a look at our average daily usage. And so that average daily usage field is right down here. That's connected to those parameters that we saw on the coverage group. I can turn this to 0, for example, and then select calculate average daily usage. And it's going to use those parameters that we just set on the coverage group in order to calculate that average daily usage. I select it, and it's telling me that on average, I use 1 a day. Okay. And so DDMRP needs to have an idea of how often this item is being essentially removed from the inventory. And that's what the ADU is doing for us. When it comes to the calculate min, max, and reorder point quantities, we have our decoupled lead times, our ADU, and now we can manually or automatically configure our finished goods items, our finished goods minimum, reorder point, and maximum. We can toggle these and change these manually if need be, or we can use that ADU and we can use our decoupled lead time in order to calculate them for us. So let's see what it does. Okay. So based on the decoupled lead time, the average daily usage, and different factors that we have set up in our parameters, it's developed minimum, reorder, and maximum quantities of 20, 30, and 40 respectively. And so now that we know, now that we've input the parameters and data necessary in order to calculate these in the future, we can set up DDMRP to recalculate these values on a regular basis. We can also enter an order spike threshold, which is going to tell the system, hey, if, for example, we consume over a particular amount in a given day, the system's going to take the excess, let's say over 30, and factor that amount of demand back into this calculation in order to give us a better minimum, reorder, and maximum quantity. That then feeds into the planned orders that are generated with a priority on top of them. Okay, so that's a lot, but let me just point out real quick the workspace that we can use along with this. So if we go over here to our modules, master planning, and demand-driven MRP. Okay, as mentioned, I'm running this locally, so I don't have access to plop, planning optimization. But if I did, I could run this and use this dashboard here, which is going to show orders that are below that minimum, between min and reorder, above reorder, what's considered critically low, on hand low, so on and so forth. So it's breaking down all those different ranges for me. And like what we saw on the other master planning workspace, we can also see a lot of our various fields here. We'll have our numbers still available to us to click into the planned order, as well as its referenced item, the requirement quantity. Okay. And so what's really going on here, as well as that planning priority, very importantly over there. So what's really going on here is we're creating planned orders based on consumption, not necessarily based on demand. So we're not necessarily tracing directly to specific demand, such as a sales order, but we are taking all of that demand and indirectly using it in order to calculate minimums, maximums, and reorder points based on a modified lead time for an item. Okay. And so it's actually quite advanced. We're taking into consideration the imperfect world that we live in when it comes to supply chain management, not being able to always get everything in on time, but still having enough when we need it in order to get our production orders fulfilled on time. At the same time, not having too much in the warehouse. So it's pretty cool. It's a great system, and you can learn more at the DDMRP Institute, DemandDrivenInstitute.com. So thank you very much, and hope to see you again in the future for one of our production order videos that's going to dovetail with this one. Thank you. Bye-bye.